So now I want to talk about the ratios of the masses and in a nuclear disintegration and the ratios of the masses produced when a nuclear disintegration occurs and the momentums and the velocities and how these are all related. Okay, so if we take we take a radioactive element and it splits into another radioactive element plus maybe an alpha particle. Okay, so if we have the ratio of the masses as being, this is the mass of M1 and this is M2, okay? So that has a mass of M2. So if we look at the ratio of the masses M1 over M2, we're interested in that, okay? Now, or we might just be interested in the ratios of the momentums or whatever. Let's have a look at momentum first. The momentum at this side, momentum is 0 because momentum is mass times velocity by definition. So this has a mass, but it has no velocity. So that means on this side, the momentum has to be 0 because momentum is preserved or conserved. Okay, so that means that M1 times its velocity, V1, so that will have a V1. This will have a velocity V2, okay? So M1 times V1 plus M2 times V2 has to be equal to 0. Okay, now that means that M1 V1 is equal to minus M2 V2. The minus in this situation just indicates the velocity in the opposite direction. Okay, so the minus only indicates direction, not magnitude. From that we can see that M1 divided by M2 is equal to, now if we divide by M2, so actually we'll just do it slowly, M1 V1, if we divide both sides by M2, we get V2, and we do have a minus, but that's just direction. Then we divide both sides by V1, we get M1 over M2 is equal to V2 over V1. So that's very important, okay? So if a nuclear disintegration takes place, then, and if that is such that you get two products, then what we're saying is the ratio of the masses of product 1 to product 2 will be equal to the velocity of product 2 over product 1. So remember, that's counterintuitive, so be aware of that. Okay, so that's true. What about the ratios of the kinetic energies? So the kinetic energy of this first mass, M1, the kinetic energy will be a half M1 V1 squared. The kinetic energy of M2 is a half M2 V2 squared. Okay, now, the halves will divide top and bottom, okay? So that gives you the ratio of the kinetic energies is M1 V1 squared over M2 V2 squared, okay? That is the ratio of the kinetic energy 1 over kinetic energy 2, which is equal to M1 over M2. Now, what's V1 over V2 squared? Well, I'm just going to, again, mathematically, for those of you that aren't sure, that's the same as M1 times V1 squared over M2 times, okay? Which is equal to M1 over M2 times V1 over V2 squared. But we already know that V2 over V1 is M1 over M2. So V1 over V2 will be M2 over M1, okay? Just turning both sides, get the reciprocal of both sides. So instead of the V1 over V2, we can put M2 over M1. So then we get the ratio of the kinetic energies will be M1 over M2 times M2 squared over M1 squared. Now, hopefully you can see from that the M1 squared, so you get basically, you'll get M1 M2 squared over M2 M1 squared, and M1 divides in M1 times here and the top once, M2 divides into the bottom and it goes into M2 squared M2 times. So we end up with M2 over M1. So the important point here is the ratio of the kinetic energies of the two products is the ratio of their masses, but it's the inverse. In other words, kinetic energy 1 over kinetic energy 2, the kinetic energy of mass 1, M1 over the kinetic energy of mass M2 is equal to M2 over M1. Okay, so what are the two things we came up with here? We came up with that the ratio, in the first bit we had that the velocities, that M1 over M2, I think it was, is equal to V2 over V1. So the ratio of the masses is the ratio of the velocities, the inverse ratio. That's one important thing. And we also then came up with the ratio of the kinetic energies. Kinetic energy 1 of mass M1 over kinetic energy of mass M2 is M2 over M1. Okay, so there are two important factors.